So in this section we're learning about the product and quotient rules. The product rule is when you have more than one function, we're going to call them functions being multiplied together, and the quotient rule is when you have rational functions and you're trying to take the derivative. Higher order derivatives we'll get to at the end. Basically that's like taking the derivative of a derivative. It's pretty fun. Okay, the product rule is what we're starting off with. The product rule is useful for functions that have two or more, in quotes, functions being multiplied together. Really, this is all one function right here. But what we're going to do is we're going to treat this as two separate functions being multiplied together, f times g. The first function would be this guy right here, and the second one is that guy right there. We'll call that f, and we'll call that g. I don't know why they chose f and g, because of the fact that we have this f of x sitting over here. Some people sometimes get confused. This is notation for the original function. F and g are what we use for the product rule. Okay? So don't get confused by those two things. The product rule is simply this. Very simple. Right? Okay. If you look at this, read it for what it says. All it says is the derivative of my function, which I'm defining as two different functions being multiplied together, is equal to the original f times the derivative of g plus the original g times the derivative of f. Okay? Yeah, you'll hear me say the original g quite a bit. But you know what? You'll remember it. So the shorthand for this will be the derivative of this function using the product rule. The product rule shorthand is f prime g plus g prime f. That's what you need. If you can remember this, then you'll be able to remember this. Maybe not in the fancy format that it's written in, but you'll be able to do the product rule very easily. Okay, the important note at the bottom. An answer is considered simplified if like terms have been combined and there are no negative exponents. If you meet those two conditions, the answer is simplified. We are going to have simplifying to do with this product rule situation here. Okay? I'm not going to derive where the product rule comes from, but it does work every single time, as long as they have two different functions here. So, here we go. Examples using the product rule. Find the derivative of h of x equals that. First, obviously, we could just FOIL this out, right? And then we could take the derivative. Or we could use the product rule. We're going to do both, just to show you that the product rule does end up with the same result as if you had FOILed this out. So the first thing we need to do is rewrite this. H of x equals, FOIL it, we get 3x times 5 is 15x. 3x times 4x is plus 12x squared. And then we have minus 10x squared, and then minus 8x to the third, right? Okay. Combine like terms, write everything in descending order. So I get h of x equals negative 8x cubed plus 2x squared plus 15x. Okay, so now it's FOILed out, and now we can take the derivative using what we've already done, the FOIL method. So just take the derivative of this polynomial. It's h prime of x equals what? Negative 24x squared plus 4x plus 15. Okay, so that would be our answer if we just FOILed it out to begin with. So that better be our answer for the product rule, okay? What was the product rule? Do you have it memorized yet? F prime g plus g prime f. Okay, very easy to remember if you're remembering the f's and g's. Okay. All right, so we need to define what is f and what is g. This guy right here is going to be f. This guy right here is going to be g. All right. Now notice that it is two functions now. This is f and this is g, and they're being multiplied together. That's the crucial thing that you see in order to use the product rule. So I'm going to go straight into h prime of x equals. Now, the product rule tells me take the derivative of f. So I'm just going to be very formal, and I'm going to write all this out, and I really recommend that you do as well. The derivative with respect to x of f, oops, I don't want parentheses there. I'm using brackets if I'm taking the derivative, of 3x minus 2x squared times the original g, which is 5 plus 4x, plus g prime now, so I'm going to write the derivative with respect to x of 5 plus 4x times the original f, which is 3x minus 2x squared. That is the notation for what you're doing here. For these first few problems, that's how we're going to write this out. Down the road, we won't have to do that. We'll be able to do this entire problem in our head. So that's h prime of x equals. Now we can take the derivative. That's what this says right here. Take the derivative of that piece. What do we get? 3 minus 4x times that. Next. Plus the derivative of this piece, which is just 4 times okay. Now it's really important that you understand that you're not taking the derivative of each piece, right? That's why I wrote in this notation. This we're taking the derivative of, this we're not. This we're taking the derivative of, this we're not. Okay? Got to pay attention. All right, now here's the funny thing. In this particular problem, we wind up having to FOIL anyway, and distribute, and then combine like terms anyway. So this method for this example is not the best, right? I would much rather do this than all of this mess that we're handling here. But later on, we will have to use the product rule. We'll have no choice. So I need to distribute 15. Good. 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 And obviously we're going to have some like terms to combine here. H prime of x equals we need to go with negative 16x squared minus 8x squared, which is negative 24x squared. And then we go to the x terms. We have 12x minus 20x, which is negative 8x, plus 12x, which is positive 4x. We only have one constant term, plus 15. Did we get the same result? Yeah, we do. So that's one example of how the product rule does work. That doesn't prove the product rule works. If you want a proof, I think it's in the book, actually. I'm sure everybody's going to study that pretty tough, right? Yeah, for sure. Don't worry about that. It works. Find the derivative. In this particular problem, you'd want to FOIL it and then use the product rule. But we're not going to do that. We're going to use the product rule. So we write f prime of x equals what? The derivative with respect to x. So d over dx of 6x plus 5, that's f prime. We have f here, we have g here. That's a bracket, thank you. Okay, then what? Okay, so just to recap what happened here, this is f prime, this is g, this is g prime, this is f. F prime g plus g prime f. Okay, take the derivatives. Okay. This one actually is easier than the other one, which is nice. 6x squared minus 12 plus 12x plus 5 squared plus 5x. Wow. Let me pay attention. 10x. Okay, am I right now?
Yep.
All right, so one more step, combine like terms. F prime of x equals good. Okay, product rule again. What do? Do you see that it's a product rule problem? The function out here is f, this guy here is g. G prime of s equals the derivative with respect to s of s to the 1/2. I like it. Rewrite it when you can. Times. Okay? Of okay? Now what? So g prime of s equals, so the 1/2 comes down, s to the negative 1/2. So I'm going to write that as 1 over 2s to the 1/2, right? Okay? Times 4 minus s squared plus negative 2s times s to the 1/2. Okay, g prime of s equals what? Now what?
Minus.
3/2. So here's what happens. This denominator can be split and make two fractions here. So you wind up with 4 over 2s to the 1/2 minus s squared over 2s to the 1/2. That reduces. Then minus the 2s to the 3/2. Okay? So this becomes 2 over s to the 1/2 minus, there's a 1, 2 divided by 1/2 in the exponents. We subtract, so we get 3/2 in the denominator or in the numerator? In the numerator, it's a positive 3/2. So it's 1 s to the positive 3/2 over 2 minus 2s to the 3/2. Do we have like terms here? Yeah, we have s to the 3/2 here and here. So these are like terms. That's a negative 1/2 s to the 3/2 minus 2s to the 3/2. So this is 2 over s to the 1/2 minus 1/2 minus 2, which would be negative 2 1/2. So negative 5 s to the 3 halves over 2. You want to know what's really fun? You can make a common denominator here. Multiply both sides. Multiply the top and bottom of this one by 2. And multiply this side by s to the 1/2. That's one of the most frustrating things about this class, the algebra afterwards. So this becomes 4. I'm really out of room, so I'm just going to go here. This becomes 4 minus, you're multiplying like bases, so you add the exponents. 3 halves plus 1/2 is 4 halves, which is 2. So that would be 4 minus 5s squared over 2, technically square root s, right? There's your answer.
Oh, thank goodness we can leave it like that.
A little note. Couldn't I just distribute that there and get g of s equals 4 s to the 1/2 minus s to the 1/2 times s squared, add the exponents, s to the 1/2 s squared, 1/2 plus 2 is 2.5, which is, now couldn't I take the derivative like that? Yeah. Would have been a lot easier, okay? So the point that I'm trying to make here is you guys are going to be given these nice fancy ways to solve problems. Doesn't mean that you need to use them, okay? You can still use your skill set from what you've learned before. So just be careful. You don't have to use product rule here. In fact, look what happens. It's brutal. This is much easier, okay?